So we have to draw a graph when we have a practical function here and find minimum maximum points. We're going to find something else here and find average rate of change and instantaneous rate of change. This is a standard exercise on Geogebra. And here we have a function f of x equals to blah blah blah, and this function is valid for x between 0 and 52, and the function shows how many kilograms an athlete weighs x weeks after 1st of January 2020. So the x is the amount of weeks. We put in the amount of weeks, and the output, the function value, is the weight of the athlete. All right. So, and the first thing we should do is draw the graph. So then we just put the function into Geogebra here. Sorry. I just need to do this here. So we just write f of x equals to 0.0017 x to the power of 3 minus 0.13 x to the power of 2 plus 2.3 x plus 72. Right. So be careful that you get the right amount of decimal numbers and so on, and then just press enter now like this, and then we can try and find the graph here, and we use this button here, move graphic field or something, and we just need to drag the y-axis so we see the graph. Here's the graph, and remember the x-axis should go to 52, so we need to go like this, right? And we should actually just draw the graph between 0 and 52. So that's the next thing we do. We use the command function start end. Start slit like this. Oh, sorry. Let's try again here. Function here. One more time. Function. And there's draw f here. Just write f. And we start at 0 and end at 52. And then enter. And we see we get another graph here, which is red. And then we can just take away the green one. Do not delete it, but just do like this, right? And here we have a nice graph. And when we have done this, we need to just remember that what is the x numbers here? This is the amount of weeks, and the y-axis is kilogram, right? So we see that he weighs about 72 kilograms at x equals to 0. That's the 1st of January. And then his weight increases during the spring here, goes down during the summer, and then it increases when we approach this Christmas again, right? So here we have the weight of the athlete. And the next question here is find when the athlete weighed the most. How many kilograms did he then weigh? So we need to find the extreme point here, the maximum point, and then we can press point here and extremalpunkt and just press the graph, and we get these 2 points, right? So this means that after approximately 11 weeks, that's when he have the highest weight, and then he weighs 83.8 kilograms. So you need to make a Word document here where you write an answer. After 11 weeks, he weighs 84 kilograms, right? And then so that's the exercise B. And then it says on exercise C here, for approximately how many weeks during this year he has a weight which is above 70 kilograms. So for how many weeks does he weigh more than 70 kilograms? And we see that he weighs more than 70 kilograms all the way up to approximately 30 weeks. Then he weighs less than 70 kilograms, and then after approximately 47, 46 weeks, he weighs more than 70 kilograms again, right? So 70 is the number here, and I would like to draw a line here through 70 on the y-axis. So just write y equals to 70. Press enter. And here we see he's above 70 and he's below and then he's above again. So we need intersection point here. Press this again. Skjæring mellom to objekt. Just press the graph and the line and we get these two answers here. So he weighs above 70 kilograms for approximately 30 weeks, and then he's below 70 again, and then he's above 70 between 47, and for the rest of the year is just 52, right? So it's 30 weeks approximately, plus this is about 5 weeks from 47 to 52, so it's 35, right? We can just give an approximately answer here. So first 30 weeks and then 5 weeks. So 35 weeks is the answer on exercise C. And then important exercise here, find average rate of change from 20 to 45 weeks. And then we first need to find his weight after 20 weeks. And after 20 weeks, let's just try and do it approximately here. After 20 weeks here, you can just press this, then he weighs 79.6 kilograms. And after 45, this is approximately, so we just try and find 45 here. That's good enough, right? 44.95, then it weighs 67 kilograms. So he's actually lost about 12 kilograms in 25 weeks, right? But the easiest way here, we don't have to think, we just need to find those 2 points approximately, and then we can use line here, line, and just make a line between, press E and then F, and we get this line here, and we normally want the line on the form y equals to ax plus b, so but we don't get it on this form, so we just have to right click here and choose this one, y equals to ax plus b, and then we get this answer. And the gradient stigningstallet here is minus 0.5, and that's the average change. In average, he loses half a kilogram per week. So the answer here is 0.5 kilogram per week in average. Minus, right? He loses down, yeah. So he loses 0.5 kilograms per week. So just find the 2 points, 20 weeks, 45 weeks, draw a line, use this thing here, draw a line, and right click and choose y equals to ax plus b, and look at the slope, stigningstal. That's the answer. That's what he loses in average here. So that's the answer on D. And then the last one, find momentarily growth, rate of change, or instantaneously rate of change when x is 12. So when x is 12, well, after 12 weeks, we're about, just let me check, yeah, sorry, can I just change this to x equals to like 30, like that. So just change this to 30, sorry, and now I'm messing up here. Just forget this line here. Let's see, we can, yes, do like this, yes. So let's take 30 weeks, find a momentarily rate of change after 30 weeks, or let's take, sorry, let's take 40 weeks, okay. 40 weeks, and explain what this tells us. Sorry. No, let's not take 40 as well. let's take 25. Okay, 25. Now this stupid thing again here. Yes, after 25 weeks, this is here. It's 25 weeks, and we want to find the rate of change here. So we can do this in 2 ways. We can find 25 weeks like this. This is approximately 25 weeks here. And then draw a tangent line here. Or the easiest way here, just like, let's make it easy. If you want to find the rate of change, instance rate of change after 25 weeks, we just take f derivative of 25. Let's do it simple. F derivative of 25, which is minus 1.01. So that means that after exactly 25 weeks, he loses 1 pound per week, 1 kilogram per week. Okay, so the answer is the moment instantaneous rate of change is minus 1.01, which means that he after 25 weeks he loses weight at a rate of 1.01 kilograms per week. That's what this tells us. After exactly 25 weeks, he loses weight at a rate of 1 kilogram per week. So that's a typical Geogebra exercise. Draw the graph. Remember, when you draw the graph, just put in the function first, then on the next line, you use function start slut to get the function in the correct interval. And then you can find extreme points, you can find when it's above 70 or equals to 70 and so on, and find average rate of change and instantaneous rate of change. So there are one exercise in each booklet, which is kind of the same as this. So try and do those exercises in the booklet. Yes.